inequalities. So now we've done linear inequalities. Now they'll be non-linear. For example, you might see something like this, and you know that it's not a line because you see an exponent on the x. So this is non-linear, but it's an inequality. So instead of an equal sign, it will be an unequal sign, and that's what I meant to write. Greater than or equal to 0. So what we want to do, first of all, we're going to actually learn to graph these coming up in the next chapter. But what we're figuring out, just for your information, is where this graph on the xy x-axis, we're figuring out where it's greater than 0, and this is 0. So in other words, we're figuring out where it's above the x-axis. So we begin by factoring, and some of them are nice and they actually factored them for you. But if they didn't factor them, we'll start the problem by factoring. So this one factors like that, and you can do that by grouping or trial and error, however you like it. And then it's still greater than or equal to 0. But what we do, we know we set each factor equal to 0. But this one, we're actually figuring out where it's greater than or equal to 0. So I still set each factor equal to 0 and solve, because what's happening is on the xy axis at -4, I'm crossing the axis, and at 2, I'm crossing the axis. Now, and so they can make a few guesses usually, and sometimes someone will typically say it's a parabola, and that's what shape it is, and we're graphing parabolas coming up. So what you're figuring out is where this parabola is above 0. So it either is going to go like this, or will be upside down and go like this, looking at the equation. But for now, the way that we do it is this. We're going to solve this inequality by taking -4 and 2, the two places where it crosses the axis. And what we do is we just put them on the number line. So it's not an xy plane, it's just a number line. Make sure you go smallest to biggest, and then you have to test each interval. So the easiest point to pick between -4 and 2 is 0. So I'm going to test 0 right there. And by test, what I mean is I'm going to plug it up here in my original and see if it's true. So if I plug 0 in right there, I get 0 plus 2 times 0 minus 8 is greater than or equal to 0. So this is 0, and all I have is -8. Is that greater than or equal to 0? No, it is clearly not. So that means every point in this interval will not be greater than 0. It's below the x-axis. So for this interval, you can pick any number you want, except don't use the endpoint, because that's where it's crossing it. So I'll pick 3. So if I pick 3, plugging 3 in, I get 3 squared plus 2 times 3 minus 8, and we're going to see if that's greater than or equal to 0. So I get 9 is greater than or equal to 0. So we can see that that's 15 minus 8, so it's 7. And that is true. 7 is greater than or equal to 0. So if it's true, what I do is I come up here and I shade this interval. I'll make it a little longer, because I know every number in that interval will make it true. Then we're going to test one in this interval. So I'm going to test -5. So plugging in -5, I have -5 squared plus 2 times -5 minus 8. So I get 25 minus 10 minus 8. And once again, that just coincidentally happens to be 7, doesn't it? Again, that's true. 7 is greater than 0. So this one, where I tried -5, that interval is also true. Now, if this is greater than or equal to, then I will write greater than or equal to. So I will use brackets. Brackets are when it's equal to. Do you remember that if it's parentheses, you use, that's when it's just less than or just greater than. But if it's greater than or equal to, that's when you use brackets. So they can go either way, but that's if it's equal to. This is if it's not equal to. That's when you use parentheses. So here's the important last step. you need to summarize this answer. So I'm going to start on the furthest left, the smallest point, which is negative infinity, and I'm going to end at the greatest point, which is positive infinity. So I will say that my answer is negative infinity all the way up to negative 4 with a bracket, but remember you never can include infinities, so they always, negative or positive, have a parenthesis. And then you're going to say unioned with, and we're going to use the union symbol, which means it can be here or here. And D. So that is your answer to this problem. And what you just found out is that the parabola looks something like this, because you know that it's above the x-axis right there and right there. Them to alternate, but you could have a parabola like this, and so you don't know that they'll alternate. You have to check each interval. Alright, let's try a rational inequality. So how about this one? X minus 3 divided by x plus 5 is less than or equal to 0. Okay, this one, this is called a rational equation, and 0. Let's figure that out. Where does the bottom equal 0? Where the bottom equals 0, so at negative 5, 1, 2, 3, 4, 5, I have an asymptote. An asymptote is an imaginary line that your graph gets closer and closer and closer to, but can't cross. It will never go over the asymptote. So it could change. It could be down here. It could be like this and like this, or it could be like this and like this. We don't even know. But all we have to do is figure out where it's less than or equal to 0. So we know that at the asymptote it can change. So that has to go on your number line. Now the other thing that has to go on your number line is where it crosses the x-axis. So we have to figure out where it equals 0. And this isn't hard because we'll just multiply by that denominator so that we can cancel it. And maybe in your notes, if you want, stick that in a rectangle so you remember that you're multiplying. Now, on the right, on this equation, I have x, and 0 times this is 0. If that were a different number, like 1 or 10, then you would have to distribute it and solve the equation. But this one's really nice to us because it's 0, so 0 times anything is 0. So I can easily solve for x. So now I know that at 3, it crosses the x-axis. So maybe it looks like this. Or the other possibility is it could look like this. Because I know it's going to get closer and closer and closer to that dotted line, that asymptote, but never cross it. But I don't know if it's like this or like this, until we figure out where it's less than or equal to 0. That is where it's below the x-axis. So what I need to do now is on my number line, I will put those 2 points, negative 5 and 3. And once again, test every interval. So let's test 0 for this one because that's the easiest one to test. So if I plug 0 in for x, I get negative 3/5 is less than or equal to 0. And we know that a negative is in fact less than 0, so that's true. So we're going to shade that. So what that means is over here, I know that between this point and this asymptote, I'm below, which means it must be this one. And this one is wrong. But let's check the other intervals. So let's make sure. We expect it to alternate, but here and 4 in here. I get 1/9 is less than or equal to 0. And that is not true. So I do not shade that interval. Let's test negative 6, which is 9. And is 9 less than or equal to 0? No, positive numbers are not less. So once again, I do not shade this interval. So now I look at this, and like our first one, it says or equal. Okay, and then since there's only one interval in my answer, I will just describe it from starting point to ending point, like that. And that is my solution. Now, that was just one example of the quadratic and one example of a rational equation which has asymptotes. So it could be a tricky assignment. Do your best. If you need more examples, email me and I will put more on Canvas in Pages.